In this video, we're going to talk about isosceles and equilateral triangles. The objective here is to use and apply properties of isosceles and equilateral triangles, very simply now. The understanding here, essentially, the angles and sides of an isosceles triangle and equilateral triangles have special relationships. So there's a relationship or relationships between the angles and the sides of any equilateral or isosceles triangle. If you look at this triangle here, this triangle is isosceles because it has these two legs that are congruent. So once we do have two congruent sides of a triangle, that's an isosceles triangle. If you notice, we have these two base angles here. They're also congruent. And we will find out that these two angles are determined by these two congruent legs. So let's look at the isosceles triangle theorem. So the base angles of an isosceles triangle are congruent. So A and B here is going to be congruent. Two sides are congruent. If two sides are congruent, side AC and side CB are congruent. Therefore, these angles A and B opposite these two sides are going to be congruent. That is basically what this isosceles triangle theorem is saying. So if I have a triangle like this, and I'm saying that this angle and that side are equal, I'm also saying that this angle and that angle are going to be equal because this here is your base, right? That's one leg and that's the other leg, right? So this angle up here is going to be your vertex angle. Right? But these two angles here are congruent because these two sides here are congruent. That is what the isosceles triangle theorem is saying. So if you have a triangle that these two angles are congruent, it means then these two sides also must be congruent. Now, this is what the converse is saying. The converse of the isosceles triangle theorem. I have two angles that are congruent. Therefore, it means that you are going to be able to say that this side over here, let me just make sure I got the drawing. It means that this side, not sure why it's not drawing, but CB and CA are also going to be congruent because that is what the converse of this isosceles triangle theorem is saying. Now let's move on to theorem 4.5. It says if a line bisects the vertex angle, this angle up top here, then the line also is a perpendicular bisector of the base, right? It means that if I have a triangle like this, and I say this is equal to that, and this is isosceles, if a line bisects means it cut this vertex angle in half, it means this will be equal to that, and this would be at a right angle, which means this line here is going to be the perpendicular bisector of the base, right? So just like it says here, CD is going to be a perpendicular bisector of the base AB. And that is what that theorem is saying. And the converse of that, or the corollary of these two theorems is, now if this is an equilateral triangle here, means all the sides are equal, hence all the angles are also equal. So an equilateral triangle must also be an equiangular triangle. So if the angles are equal, it confirms that the sides are equal. And usually an equilateral triangle would have angles of 60 degrees because remember, the triangle must add up to 180. All right, so there you have it, the isosceles and equilateral triangle theorem. We'll do some problems using those theorems.